Hey folks, welcome back. This is CSE 1322 and today we're going to start Module 3, Part 1. There's going to be a lot of parts in this module and it's going to take us a couple of weeks to get through it, but this is a lot of really important material in here. So what we're going to spend time in Module 3 talking about is object-oriented programming. There's a lot more to it than we've talked about so far, so the first thing we're going to talk about today is inheritance. So we're going to begin by talking about something called UML. So UML is a way of us drawing how a class might look. So if we were to flip over to our little whiteboard here, you might think about last week when we were talking about classes, we had a fry cook. And the way that that might look is you would draw a box for the fry cook and you would generally put a line across the middle, and up here you would list all the attributes, and down below you would list all the methods. That's the general idea, and it's useful because our fry cook class, having a visual way of representing it, would allow us to share what classes we have with another person. Okay, so the real reason that we do this is because, again, most of the time when you get a job in industry as a software developer, you're not starting off from scratch writing brand new code. Instead, what you're doing is you're taking an existing set of code and you're adding new features or fixing existing bugs or doing things to that. So when you walk in the door, you suddenly have to know what all the classes are and how they interact with each other. And that's where a diagram comes in. It's just a faster way of being able to see it. So UML stands for Unified Modeling Language. It's a way that we use to draw out all of the classes that are in a given program or in a given package, because a package is just a group of classes that are put together. Each class, as I say, is drawn as a rectangle. The name is put on the top. All the attributes are in one box and all the methods are in another. You generally don't mention the constructors in the diagram. So the good news is that most IDEs, including IntelliJ, will actually draw these diagrams automatically for you. So I'm going to show you how to do that. There's two more details that you need to know. Generally, if an attribute is public, it's going to have a plus sign in front of it. That's also true if a method is public. So most methods will have a plus. Most attributes will have a minus because they're generally private. There's another keyword that we haven't talked about, which is protected. We'll come to that a little bit later on, but protected is usually represented by a hash sign. So on front of everything, there's going to be a plus for public, a minus for private, or a hash for protected. So here's an example of a mammal. So what do all mammals have? They have a temperature, a weight, an intelligence, and a fur color. So those are 4 attributes. In this case, they're all listed as public, which is not great. We probably should have them as private. So those probably should have been minuses. And then down here we have what all the animals are able to do, which is to drink, eat, move, and give birth. So this is a UML diagram. Alright, so let's actually do this over in IntelliJ. This is the code that we're using last week when we were talking about the fry cooks and all of that kind of stuff. And so the first thing that you're going to do in IntelliJ, assuming you're using the Community Edition, is you're going to go to Plugins. Now, this is the one case where if you have bought the paid edition, you would actually get a feature that's built in. But given that you're using the Community Edition, we have to install a plugin. So what you're going to go look for is this Plant UML diagram generator, and it's in the marketplace. So if you type in plant, you should see it in here, and then you just have to check the little checkbox to install it, which will take a couple of moments. You need both the Plant UML integration and the diagram generator. You need both of those installed. They're free. They'll get installed. Once you're installed, it'll prompt you and tell you that you have to restart your IDE, and then you'll be back to a regular screen like this. Once you've done that, over on the right hand side here, you'll notice there's this new button, Diagram Generator, and if you click Structure Diagram, over on the left here you'll see it makes a new file called mainstructure.pummel, and if I open that mainstructure.pummel, you'll see it has drawn for me a diagram of my classes. You'll see here it's got hourly wage, and if I just pull up fry cook here in the background, you'll see it has hourly wage and name. And going back to the diagram, hourly wage and name, it does tell me that they're strings. It also has a do somethings and a make fries method, both of which are listed as public. Do some things, make fries are both here. And then over in the main, it shows there's a do stuff and a main as well. So it basically just draws the diagram for you. In this next section, you're going to see that there's a lot more that can happen in that diagram when we deal with inheritance, where one class might be a child of another class, but we'll come to that in a little bit. So that's the idea of a UML diagram. It's actually a useful tool. In most software development teams, you'll have 7 or 8 people that are working together, and they're working on features each week. And on their wall, there'll either be a TV screen or something like that, or a big printed diagram that has the UML for all of their classes. It just makes it easier for everybody to reference something real quick rather than having to dig through hundreds of files looking for something to figure it out. Okay, so that's a UML diagram. Now we're going to move on to inheritance. All right, so inheritance allows you to take what's in an existing class and then create a new class which is a child of that class that has all of the attributes and methods that that class made public. All right, the reason that we do it is because inheritance saves time by allowing you to reuse code. And the truth is that a lot of times if you're making a child of a class, that child has many of the same capabilities as the parent. So let's just step back from computer science for a few moments and talk about families. So you are a child of 2 parents. Those parents passed along to you certain capabilities. They taught you how to tie your shoelace. They taught you how to walk. They taught you how to ride a bike. All the things that parents do. They also passed along attributes to you. Like you have some things that you have naturally gained because your parents had them. And so that's where this word comes from. It's the same thing that's happening in code. You have one class that is passing along stuff to its children. All right, so let's take an example. Imagine we had a dog class and a mammal class. Well, we start off with a mammal and we say, what things does a mammal have? Well, it has temperature and weight, IQ, and fur. It knows how to eat, drink, move, and give birth. Those are the things that mammals can do. And then we decided we want to create a dog class. Well, one option is we could just make a copy of the mammal class and just copy all of that code into the dog class. So I'm going to come over, I'm going to start a new project here for this week, and we're going to start off and we're going to make our mammal class. So again, we begin by clicking the 3 dots and we say new class, and we're going to call it mammal. And inside our mammal, it turns out we have this temperature, weight, IQ, and fur color. So temperature, we're going to decide is going to be stored as a double. And then they called it temp, T-E-M-P. They also made it public. So I'm just going to follow the diagram. I'm knowing it's public because of this plus sign. And then likewise, there's a weight. I don't know why I have an E there, and I'm missing a semicolon. There we go. All right, and then we have an IQ, which we'll say is a double as well. And we have a fur color, which is going to be a string. All right, then it has some methods. So it has an eat, drink, move, and give birth. Public void eat. Generally, when you eat, it's not like you're returning anything. So int how much. And then we have drink, which again is going to have a how much. And then we had move, which I guess also has a direction. Well, let's say string direction and int speed. That seems reasonable for move. And then we have a public void give birth. Probably no parameters on that one because I don't want to think about it. All right, so those are the methods for mammal. So having created my mammal class, if I now needed a dog, the first option would be I could say file new Java class, call it dog, and then I could go to mammal and I could copy all of this code, and I could copy that, go into the dog class, and I could paste all of that. And that would work. And I would have a dog, and the dog would be able to eat and drink and move and give birth. But Copying and pasting code is always a terrible idea. Now let's talk about why it's a terrible idea. The problem is, let's imagine you change how give birth works. Nope, let's imagine you change how eat works. And somehow now there's extra stuff that you have to do for eat. So you go and you change it in mammal, but then the dog still doesn't do the new eat. The dog is going to do the old eat, which is the unmodified version of eat. It turns out you'd have to change it in mammal and you'd have to change it in dog because you copied and pasted the code there. And so any fixes you make in mammal, you have to remember to make them in dog. And that doesn't sound too bad until I tell you that I want to make Animal Farm and I want 700 different animals. Well, now you've got to change it in 700 files. And the chances that you're going to remember every file that's out there is not very high. It's also the case that if we were honestly creating some kind of a farming game, the chances are you're not the one who wrote all the animals. So you may know about the cows and the pigs and the sheep and the goats, but somebody else may have written about the giraffes and the elephants, and you may not even know that they exist, but they do. And so you would have to modify code that you didn't even know was out there. So copying and pasting code is a terrible idea. I can achieve this exact same goal in my dog class by doing the following. Public class dog extends mammal. Okay, at this point, the dog is a child. It has inherited from mammal. And so if I go back to here and I ask it to draw me the UML diagram like we've done before, when I pop that open, what you're going to see is that the dog is now a child of mammal. It drew an arrow from dog to mammal. It's no longer a separate class off to the side, it's actually a child class. So this is how you should do children. You simply use the extends keyword on the class description. So we can now make a dog, a cat, and a cow, or a whole bunch of mammals. Each of those mammals would be a child of mammal. And so you create mammal once, you put all the main things that mammals do up there, and then you simply say dog, cat, and cow extend mammal, and they all will inherit. So what has that done for you? Well, let's ask this question. As it stands right now with this dog class, so literally what you see on the screen here, how many attributes does a dog have? And the answer to that question looks like it should be 0 because there's nothing here, but it's actually 4. If I go over to main and I clear out all the boilerplate code that IntelliJ puts in here, boom, 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 alright, I can say dog, my dog equals new dog. And then I can say my dog dot IQ equals 100 because he's a really smart dog. Okay, that's not that smart, but smartish. And you might say, but how am I able to set IQ? I didn't make an IQ in dog. There is no IQ attribute here, but it's in mammal, and therefore it's inherited down to dog. It actually notices that that has one usage now, whereas all the other ones have no usage, because I'm actually utilizing that IQ in this dog, even though I haven't actually put an IQ into the dog. So the beauty of inheritance is that all of the attributes and all of the methods that are public or protected, we'll get back to protected later, in the parent automatically are available to the children. So methods that the parent had, the child now has. All dogs immediately, with the code that is on this screen, all dogs are able to walk, give birth, drink, talk. Is that true? Was walk one of them? Move. Okay, they all know how to eat, drink, move, and give birth automatically because they inherited that from mammal. There's no need to redeclare them, and in the UML diagram that it drew, this is correct. It doesn't show all of those attributes and all of those methods again because it's implicitly there because of the arrow, which implies that it's a child of mammal. Alright, so now what can you do with your dog? Well, dogs can now have their own separate things, separate attributes that you might want to write, or separate methods, because in addition to the things that mammals do, maybe dogs have some unique things that they're able to do. So for example, the dog can have a bark. Woof. That's what dogs say. Pretty sure. Okay, so the dog can say woof because that's what dogs do. Mammals don't have a bark because it's not implicit that all mammals have it. So you put things in the parent that you know is going to be true for all of the children. All mammals are able to do this, whereas the dog may have very specific things that the dog can do that not all mammals can do. I can also have other classes here. So let's go ahead and make another class. This time it's going to be cat. And again, the cat is going to extend mammal. And this time it's going to have a public void per 2Rs. Let's go with per. System.out.println per. Okay, so dogs bark, cats purr. Everybody knows how to give birth, dogs and cats. Everybody knows how to move. Everybody knows how to drink and eat, but they got that from their parent mammal. In addition to this, there can be specific attributes that some mammals have. So, for example, all dogs may actually get a name. Whereas that wasn't true for all mammals, because we don't generally name all mammals, but we definitely name dogs and cats. String name. Alright, so you can have attributes that are unique to each of the classes, you can have methods that are unique to the classes, and then the other thing is you can have overrides if you have a method that you inherited that you don't like. Okay, so let's take an example of this, and we're going to choose one of these carefully. So the way that a dog drinks versus the way that a cat drinks is actually legitimately different. Fun fact, if you watch a dog drink out of a bowl of water, what they do is they smack their tongue on the water, it causes the water to jump in the air, and then they grab it out of the air. Smack the water, grab it out of the air, smack the water, grab it out of the air. Cats, on the other hand, they make a little scoop, and they scoop the water out and drink it. So they drink very differently. So that's different from other mammals. Like, I don't do either of those things when I drink. I use a glass, and I'm a mammal. So generally, each of us may have our own different version of how we do it. So if that's the case, in the dog class, you might need to override, we've seen this before, public void drink. Actually, I think it takes in how much. And now you can have your own version of how you do it. Alright, no idea why we know that, but here we are. So you now have your own version of that. So to be clear, what happens is, whatever we write in here in mammal is how the cat is going to drink, because it doesn't have an override. But because we do have an override in dog, if we try to ask the dog to drink, it's going to run this code instead of running that code, because we have overridden the stuff that came. If you think about it this way back in human terms, you inherited a bunch of capabilities and a bunch of things from your parents. But for some of those things, you've chosen that you don't like how your parents do it. And you've decided to override that and do it your own way. And that's the part of being a kid, or overriding your parents' decisions and becoming an adult. So sometimes you get to change what you inherited from above to make it so that it's working differently, because that's how it needs to be. So again, an override is done in Java by simply putting the word override above it with an @ sign. This again is called a compiler directive, and I'll talk a little more about that in a minute, and then giving a new definition to the method. It is a requirement that the method header must match the original method header in the previous parents class. So you'll notice that it's public void drink with one parameter, and it's public void drink with one parameter here as well. I can't change that if I'm doing an override. Alright, and then we do say, don't forget there are two different words here. There's override and there's overload. I'll just briefly refresh you on that. An overload is where you have the same method but with different parameters. You have an overloaded method. An override implies we're doing inheritance, and you've decided to override what your parent gave you and have something new as your own definition of that method. Alright, a little more terminology. When we create a class, that is a child of another class, we say that that class is the parent's class. So here we had a mammal, a dog, and a cow. A cow is a mammal. A dog is also a mammal. So this is an important thing because this is can become a test. If you think about it for just a moment, a dog really is a mammal. A human is also a mammal, and a cow is a mammal. But let me ask you it the other way. Is a mammal a dog? No, not all mammals are dogs. I'm not a dog, so therefore therefore mammal is a dog is not true. So is-a only works in the direction that it should work, or that it actually works, which is children is a parent. Mammal is called a superclass, a parent class, or a base class. These all mean the same thing. In Java, you will generally call them parents or super. In C#, which we'll look at the end of the semester, they're called base classes. Dog, cat, and cow, these are the children. They're either called child classes, derived classes, or subclasses. But again, the most common one is going to be child. So we use nomenclature that makes sense because we know them in the human terms. And so child, parent, that makes a lot of sense. You can also have a grandparent because you can have more than one inheritance. You can have a dog, which is a child of mammal, and then you can have a chihuahua, which is a child of dog. So there can be two layers in there. All right, so here's the inheritance example. We have class mammal. It has a public float weight and a public IQ. That's an int. Class dog extends mammal. It automatically gets those two attributes without you having to write anything. And so down here we can say dog D equals new dog. This makes us a new dog, which is a mammal because dogs are mammals, because they're children, because they extend mammal. As I said, you can go more than one. So mammal, dog, Labrador. A Labrador is a dog. A Labrador is a mammal. It actually works all the way up the chain. And a mammal has a string fur color. All right, so examples of overriding a method. If you inherit a method from your parent, but you need to do things differently, you'll override the method. So here we have mammals, which know how to speak, and they just say generic mammal noises. But our dog knows how to speak. He says woof, and our cat might know how to speak. They say purr, meow, or whatever. Each of those would override it. So what this gives you is all mammals have a default speak method. And so no matter what, they're all able to speak. But specific mammals would have a very specific version of that speak method that talks in their language or in their way of speaking. As I said, the @override keyword is technically optional in Java. I said this when we were talking about an override of toString in a previous lecture. You will always want to include it even though it is optional. And the reason you want to include it is it allows Java to check that you are actually doing a successful override. Okay, so what does that mean? If we take our public class mammal and it has a speak method, and then in dog we decide that we're going to override that speak and we say public void speak and we print woof. We take this code and we compile it and we get no compile errors and everything looks reasonable. However, when we ask our dog to speak, it says generic mammal noise. And we say, well, that makes no sense. It should say woof because I overrode speak. Well, if you stare at this for just a moment, you'll realize there's a typo. This does not say speak. Well, this says speak. This does not say speak. S-P-A-E-K instead of S-P-E-A-K. A very simple mistake to make, a very hard thing to notice when you look at it, because you probably didn't even notice it the first couple of times because it's so close that you don't even notice that it's a typo. So as a human, you would read this and not be able to tell why you're not getting woofs from your dogs. You're getting generic mammal noises from your dogs. And you would say, something's wrong, something's broken, I don't understand. The answer is, you didn't actually override. Had you put the @override on front of this like you were supposed to, Java would have kicked it back and said, there is no SPAEK method in the mammal's parent, or in mammal. It would have known that this is not a successful override. So that's the reason for the @override keyword. It allows Java to check that it really is successfully overriding something that it inherited from the parent. And if it didn't override something, it kicks it back and says there's an error. Without it, it will silently fail. So now there's a speak method and there's a spake method, whatever that is, in mammal. Both of those methods are here. One did not override the other because you didn't successfully override. So be careful of that. Always use the @override. It allows you to check. All right, so the next thing to be aware of is that every class you have ever written since the beginning of time in Java is actually a child of a magical class called object. Object is a class that exists in Java, and everybody is a child of it unless you say otherwise. So very specifically, over here my mammal class that I created, public class mammal, is actually a child of object. And then dog is a child of mammal, which is a grandchild of object. Everybody, in the end, goes back to object. Object is spelt with a capital O. It's automatically created in Java. It's also automatically created in C# when we get there. And it is the root of all objects. You don't have to specify that you're inheriting from object. It implicitly is there. So honestly, this really says class dog extends mammal. Oh gosh, sorry, I'm on the wrong screen. Ignore that. That is not what I meant to type. Class mammal extends object. That is really what's actually happening. This is implicit. You don't have to write it. It actually says class mammal explicitly extends this. I don't know why you're doing that. It's redundant because it automatically is going to do it. But that is what's actually happening. Your mammal class is a child of object. Object as a class has a bunch of methods in it, and this is now going to finally answer something that we talked about a few classes ago. We said that if you want to print out an object, you have to override something called toString, and at the time I kind of hand-waved and said, there's this magical method called toString that's just always there. The reason it's always there is because toString is defined in object. The parent has a default specification for toString, which tells it to print out the name of the class followed by the memory address after an @ sign. That's why when you print out an object, you get that weird memory address. And so just to prove it, I'm going to take out this extends object so you know there's nothing hinky going on here. And over in main, I made a dog, and now I'm going to print that dog. System.out.println, and I'm going to print out my dog. And again, what you're going to see here is it's going to print out dog at and then some weird memory address. There it is, dog at 5F184F36. If you run this on your computer, you'll get a different address because the available memory on your computer is different than the available memory on mine. But this happens to be where that dog is stored on my computer. So this is not very meaningful, but this is the behavior of toString that you inherited from your parent. Have you ever inherited anything from your parent that you didn't appreciate? Yep, that's how toString is going to always feel. toString pretty much is always going to want to be overridden. So in the mammal method, I'm going to @override public string toString, and what I'm going to return is I'm a mammal and my, do they have names? They don't. My weight, IQ. How about my IQ is plus IQ. Okay, so now when I run this, back in main, there we are. Oops. When I run this, I'm now going to get something different. Instead of it just printing out dog and address, I get I'm a mammal and name IQ is 100. That's because I typed something stupid. Yes, I did type something stupid. And my IQ is 100. Okay, so there's a couple of things to notice that have gone on here. In my main, I made a dog and I set the dog's IQ to 100. The default for all mammals is that their IQ would have been 0 because I never set it in mammal. There's nothing in here that ever sets IQ. So when the dog was created, it would have inherited an IQ that was 0, but because I then went through and changed my dog's IQ to 100, the dog now has an IQ of 100. So the other thing to notice is that I'm able to call toString on dog, even though I didn't declare an override in dog, I declared the override in mammal. This is the override that I put in. So dog inherited this override. It inherited the new version of toString from its mammal. And that's a really important thing to notice. You have object at the top, you have mammal underneath it, and then you have dog underneath that. Object had a definition for toString, which was to print out the stupid thing with the memory address. Mammal overrode that and said, no, 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 we're going to print out I'm a mammal and my IQ is blah. The dog inherited the mammal's version of it because it's a child of mammal, which is pretty cool. If you put this in another perspective, you could imagine a circumstance where a video game has characters, good characters and bad characters. So let's imagine that you're going around and you're trying to get rid of all the bad characters. Well, each bad character is going to have different capabilities. Some of them are going to walk, some of them are going to fly, some of them are going to shoot things at you, some of them are going to do other things to you. So each of the bad characters is going to have its own versions of some of these methods, but they're also going to inherit from above. So you might have a structure that looks something like character, of which there's good characters and bad characters, and then under bad characters you might have flying bad characters, walking bad characters, and crawling bad characters. Under walking bad characters you might have zombies and pirates. I don't know, I'm making this up. And then under pirates, you might have seafaring pirates and, I don't know, some other kind of pirates. I'm out of ideas. So each of them may have their own definitions where they're inheriting some amount of the stuff from above. And so effectively, if they all walk the same way, then you would define that at the top in walking bad guys. And then everybody inherits that same ability to walk. But if they're each going to attack you in different ways, then you would have a different attack method that you overrode in each one of them with some default attack method coming from above. So maybe the default attack method is that they run up and smack you across the face. I don't know. And then if you want each of them to do something different, you override that. But a new character that you create, you suddenly decide now your game is going to have chihuahuas, which are bad characters. Well, they're still going to be able to walk up and smack you in the face because they're going to inherit that from above. Not really sure how a chihuahua does that, but we're going with the example. So the point here is that there's a tree structure where the things at the top are inherited down to all of the children, and if the children don't like it, they can override it. But that happens at each level. So it may be that bad character doesn't have very many definitions because it's kind of generic, it's way up at the top. But then walking bad characters have definitions for walking, whereas flying bad characters don't have definitions for walking, they have definitions for flying. So the move method may be overridden to walk in one set and to fly in another, and then all the children of each of them automatically inherit the flying capability or the walking capability depending on who they're a child of. So all classes automatically inherit from object. Anything that is declared at the top is automatically inherited down as long as it's public or protected. And if you don't like it, then you override it to specifically tell it something else. Alright, so we mentioned this before. Class mammal has some attributes, and class mammal is really an extension of object because everybody's an extension of object unless you specify otherwise. Alright, we've also talked about overriding toString, and so here we have mammal, which extends object, and it has some attributes, and it has a constructor. And then we have dog, which extends mammal, and it has an override of toString. And so down here, when we make a dog and we print it out, we get that override of toString, which is actually directly accessing some of the attributes that were in the parent, because weight is available, so is IQ, and so is, well, those are the only two that are in here, the weight and the IQ. But in actuality, all of that's available to the child because it inherited it from above. Now, you will notice that, in fairness, we made these public, and since they're public, you could actually use them down here in main as well. You could actually say d.weight or d.iq, and you could change them or read them, and that would work even without the inheritance. But the correct behavior is these probably shouldn't have been public, they should have been private, and then you should have had getters and setters that were public that this inherited. And then if it needs to change them, it would call the getters and setters. Okay, so this magical object at the top, what methods does it have? Well, it has a whole bunch. we've mentioned toString. That's a popular one that you need to know. And later on we'll talk about some other ones, but equals is an interesting one. This tells you whether two objects are equal to one another, whether it's the same object effectively. Many of these other things we'll come back to later on in the class. Alright, so the next thing to say is that inheritance can only be from one parent. This is where the analogy to humans kind of breaks down. Mostly for us, we are children of two parents, and we inherited stuff from both of them. But in coding, specifically in Java and in C#, we made a conscious decision that you could not inherit from two separate parents. And the reason for it is because of this. Let's imagine you have a man, which has wait and a run method. And then you have wolf, which has number of puppies as an attribute, and it has a run method. So they both have a run method. If you then had somehow been able to create werewolf, which was a child of both man and wolf, which run method would you end up with? And the answer to that is, I don't know. There's two of them that I would have inherited. I don't know which one I would have gotten or which one would have won, and this becomes a problem. So this has a name in computer science, which is called the triangle of death, and it's because there are the diamond of death, sorry, not the triangle. Because there are two parents, they can each send the same thing to the child. Java and C# decided to outlaw the ability to do this. C++ actually allows this, which is another programming language, but it has to deal with that problem in a really weird way. So Java does not allow this. You can only be a child of one parent, so you can only extend one class at a given time. So we'll come back to that later, and we'll talk about something called interfaces, which is how they got around this. The next thing to talk about is the super keyword. This one you won't actually use very often, and I really hate bringing this up because the moment I show this to everybody, you start putting super in front of everything because it's like super X, super Y, super do stuff. Stop it. You don't need the word super all the time. It's a pretty rare circumstance when you need super, but let's talk through it. So what super allows you to do in a child, you may need to be able to call a parent's version of a method. So let's take a look at this example. Let's assume that dog here has a talk method, and that says woof. And then let's give the same talk method to our cat. So I'm going to copy that. I know said don't ever copy stuff. Oh, I just needed to rename it. There is talk here as well, and I'm going to go ahead and put a talk method up in our parent as well. So there's the talk method, and it's going to say I'm a generic mammal. Okay, so there's a talk method in the parent, there's a talk method in the dog, which is an override, and there's a talk method in the cat, which is an override as well. Now, you could certainly argue, if you're going to override it in both the dog and the cat, why did you ever put it in mammal? But sure, we're going to go with that. Okay, so what I want to show you is why you would ever use the word super. So in my main method here, I create a dog and I print out the dog. But instead of printing out the dog now, what I'm going to do is I'm going to ask the dog to talk. So I'm going to say my dog dot talk. And what I would expect the dog to say is woof, because that's what dogs do. And there we go, we get woof. I'm going to go ahead and create a cat. And then I'm going to ask the cat to talk. And not surprisingly, after the woof that I get from the dog, I'm going to see a meow from, or a purr from the cat, because that's what we told the cat to do in the cat's override. All right. What happens if I needed to, for some reason, print this first and then print meow or woof? That's where we would use super. So inside of the override for talk, I can say super, and that's going to call the parent's version of talk. It's unhappy with that. Call to super only allowed. Oh, sorry, it's super.talk. There we go. All right. So now when I run this code, this is only in the dog. I call super.talk. What I'm going to get here is, if it will allow me to run my code for some reason. Oh, I'm in mammal. What I'm going to get here is the dog is going to say generic mammal and then woof. and then the cat's going to say purr. So the cat comes from here, but the dog now does two things. It does what the parent does, and then it does what the dog does. This is a common occurrence where you override a parent's capability, but then you realize I actually want most of what the parent does, but I just want to change this one thing. So, the way that your parents answer their phone, you probably need to inherit some of the capabilities of answering the phone, the same that they do, but then you're not going to answer the phone very formally with, "Hello, how are you today?" You're going to say, "Sup." And so you're going to change the behavior, but you want most of the capabilities that the parent had. And that's where the super keyword is going to come in. So you say super dot and then the name of the parent's method. So again, let me be clear. This is only if you're in a method in the child that's an override and you want to call the parent's version of that overridden method. If you're calling any other method in the parent, you don't need super. So for example, if I wanted to, let's give birth. This is completely weird. System.out.println. I'm giving birth. Ooh, that is a lot of curly braces and quotes. There we go. That's what I was looking for. Okay, so the parent simply prints out I'm giving birth, and in the cat, every time it's asked to talk, it gives birth. I don't know. Just go with it. In that case, I don't need to say super. You'd be very tempted to say super.giveBirth, and that certainly will work, but the super is completely unnecessary here. You can simply say give birth, because the cat inherited give birth from the parent, and it's automatically there. The only reason that you need the super here is because you've just overridden talk. If you say talk in here without super, it's going to call itself, which is certainly not what you want. The super refers to, I really want you to call the talk method in my parent. So this super.talk allows you to call the same method that you're currently overriding in your parent. You only need to use super in that one circumstance. Again, any other method you want to call in your parent, you just call the method. You don't have to do super. So here we go. We have make noise. The parent says, "Ow." The dog overrides that and adds in a woof, but before that, it does super make noise, so you're going to print out "ow" and then woof, which makes no sense either. It's right up there with the cat giving birth every time it talks. I'm not sure what's happening. All right, so how about constructors? Are constructors inherited? They are public, so by the definition that I gave you that all public methods are inherited, it seems like they would be inherited. So remember, a constructor doesn't have a return type, and it has to be named the same as the class, and then you can take in parameters in whatever you want to take in. So in this default constructor, I might say temp is equal to 100, the weight is equal to 1, the IQ is equal to 1, and the fur color is equal to black. Okay. So this is a default constructor, and I can add an overloaded constructor. Remember, overloaded means it has the same name, but it has different parameters. All right, so here's my overloaded constructor, and in this constructor I'm going to take in a double, which I'm going to call T for temperature, a double W for weight, a double I for IQ, and a string F for fur color. And then I'm going to set temperature to T, weight to W, IQ to I, and fur color to F. So now I'm able to take in all the different types and I'm able to set them. And this is my overloaded mammal. What are you complaining about here? Two related problems. Okay, not really sure what it's complaining about. I think it's that the child needs to have a, well, I don't know what it's complaining about. Let's see. Let's try running this and see if we actually get an error. Yeah, it's fine. Sometimes IntelliJ will underline something or tell you that there's a potential problem, and then it just goes away when it has a moment to actually compile everything and figure it out. So there was no issue here. Okay, so this created two constructors, and each of those constructors set things in the parent. All right, so now when we make a dog, it implicitly has its own constructor. So remember, the rule is that in Java, if you don't give a class a constructor, Java gives it one for you. And no matter what, when you create a dog, it has to call the constructor. So it has to make a constructor for the dog, and then it has to call that constructor. All that the constructor would be for the dog is it'll initialize the one local variable that we have here, which is name. So I'm going to go ahead and explicitly create it. So public dog, and I'm going to say name is unknown dog. Okay, so there's a couple of things about constructors that I want you to see. The first is that you can have as many lines in here. Usually you're just going to be setting a variable, but there's no rule that that's all that you can do. You can actually do anything you want in a constructor. So I'm going to print out I'm constructing a dog. All right, because that's what a constructor does. It's constructing a dog. And up in my parents class, I'm going to print out I'm constructing, yes, I do need system.out. I'm constructing a mammal. Okay, and I'll do this one. I'm also constructing with parameters. Okay, so I can now tell which constructors are getting run. So when I make a dog, what I would expect to happen is that I'm going to see I'm constructing a dog, and that's indeed what I did here. When I make a cat, I currently don't have a constructor, so let me add a constructor to the cat as well. So public cat, and I'm just going to print out I'm constructing a cat. Okay, so the cat has a constructor, the dog has a constructor, the mammal has a constructor. I'm making a dog and a cat, so I would expect this to print out I'm constructing a dog, and then give me the generic mammal and the woof from the dog, and then I would expect it to say I'm constructing a cat and give me the generic or the purr from the cat. So let's run it. Let's see what we actually get. Okay, well I got a lot more output than I was expecting. The first thing that I'm getting is I'm constructing a mammal. And I look here and I'm like, but I never made a mammal. I made a dog, that's what happened here, and I made a cat, that's what happened here, but nowhere in my main method did I ever make a mammal. And neither the cat nor the dog makes a mammal. There's no mammal, my mammal equals new mammal in either of these. So why in the heck did this run? Because that's clearly what happened. Mammal's constructor ran, and then the dog's constructor ran, and then mammal's constructor ran, and then the cat's constructor ran. So all kinds of weird things happened here. So let's go back out and let's look at this. When I said dog, my dog equals new dog, I created a dog. And logically what I would have expected to happen is that the dog's constructor would have run. But actually what happened was the mammal's constructor ran, and then the dog's constructor ran. That's why I'm getting these two things. And this is always going to be the case. As a matter of fact, there's a third constructor that ran that we're just not able to see. That third constructor is in object. Okay, so the rule is anytime you create an object, if it is a child of another object, or a grandchild, or a great-grandchild, or a great-great-grandchild, or however far down the chain is, it first goes all the way to the top, object, and it fires the constructor in that class, and allows that class to initialize all of its attributes. Then, the next child, the first child, runs its constructor. Then the next child runs its constructor, and then the next child and the next child, all the way down until you get to the class that you actually instantiated. And if you think about this for just a moment, you would realize why that has to be true. Mammal has a temperature, a weight, an IQ, and a fur, and dog is going to inherit all of those. But they have to get initialized. They have to be set to some value before the dog is able to use them. And the dog could use them directly inside of its constructor. So for example, I can say with IQ, and I can directly print out the IQ right here in the dog's constructor. In order for that to be able to work, the parent's constructor, the mammal constructor, has to have already run. And so here we can see in the dog constructor, It says my IQ is 1. Please note, nowhere in here do I have an IQ. I inherited that from mammal, and the IQ in mammal got set right here. So that's why this had to run. This constructor ran first in the parent, and then the dog's constructor was allowed to run to initialize anything that's unique to the dog, like its name. And that's always going to be the case. All the way from the top, object, and then everybody below it will get to fire their constructor all the way down until the child gets to do theirs. This is what's going to happen whether you like it or not. Most of the time, it's fine, it is what you want. Every now and again, you're going to be like, oh, I really wish that didn't happen. But it is going to happen. There is no way to stop it. It is invisible code that's there whether I wrote it or not. To be clear, even if I take away this code, this will all still compile, and it still generates a constructor here and runs that constructor for me. Now it would just set them all to 0, and just to prove that point, I'm going to delete all of these lines, and I'm going to go run it again in main, and what you're going to see is that my IQ is no longer 1, it's 0, because that's what the default constructor would have done for me. It would have set my IQ to 0. I'm going to go ahead and put those lines back in there again, because I'm going to need them again in a few moments. But without them being here, the IQ got initialized to 0 by a default constructor that Java built for me that is invisible code. So there's a pile of invisible code here. My mammal is a child of object, even though I never said it is. Object has a constructor, which granted isn't invisible, but I don't really see it. Mammal gets a constructor whether I write it or not, and it gets executed. And dog gets a constructor whether I write it or not, and it gets executed. All of that happens whether I want it or not. So it's important to understand that, because all of the things along the way get to fire their constructor. Alright, every once in a while you'll want a particular constructor to be fired instead of the default constructor. Alright, so what I mean by this is, when I created my dog, I passed it no parameters. And so my dog executed the default constructor, the one with no parameters. That's why I got I'm constructing a dog with IQ blah, and it sets the name to unknown dog. That in turn causes the default constructor in the parent to fire, which in turn causes the default constructor in its parent object to fire. The mammal's default constructor set the IQ to 1 and set the weight to 1. But what happens if in the dog I didn't want all dogs to start off with an IQ of 1? Dogs are pretty intelligent. Well, I might want to be able to call a particular constructor in my mammal that allows me to set things to my own liking. The temperature, the weight, the IQ, and the fur. So to do that, I use a keyword called super. So I say super, and then I pass it 4 parameters, which are the temperature. I'll say that all dogs have a temperature of 98. I don't actually know. They all start off with a weight of 15 pounds at least. Okay, we'll do 5 pounds. They all start off with an intelligence of 100, and they all start off with a fur color of black. I'm passing the 4 parameters to that constructor, and I'm telling it, don't run the default constructor, instead run the one that takes a double, a double, a double, and a string, which in fairness is this one. Now again, I know these aren't actually doubles. I certainly could put 0.0 on each of these. 1.2, 100.1. Okay, now they look like doubles. But it would have worked either way, because an int can be up converted to a double. It just adds a .0 to the end. So this now says call this constructor in the parent instead of calling the default one. So now when I run this, back over to main, and I hit run, when my dog is created, the dog will have a default IQ of 100. Instead, 100.1 specifically, instead of a default IQ of 1, which was what was happening up here with the IQ previously. So it's basically allowing me to specify which constructor I do. So to put this in a different term, if I had done nothing, what Java would have automatically done is that. It would have called super with no parameters. This implicitly is here whether I write it or not. It is going to start off in the dog's constructor to call the parent's constructor. And likewise, inside of this, it's implicitly going to call super on object so that the default constructor and object fires as well. If you do use the keyword super, you have to make it the first line of the constructor. You cannot put this anywhere else. If I pick up this line and try to put it after that print statement, it underlines it, and when I mouse over it, it says super must be the first statement in the constructor's body. So this has to be the very first thing. And that makes sense because, again, the parent has to be able to fire its constructor first. And that has to go all the way up. So if you're specifying which constructor in the parent to call, you have to do that as the very first line in your constructor, so the super keyword has to be first. Again, the super keyword is optional. It's only there when you want to call a particular constructor in your parent. You pass the parameters inside of there, and then it does the normal matching to figure out which constructor in the parent to call, based on the type, the number, and the order of the parameters that you're passing in super. So here, this is explicitly saying extends object, which is implicitly happening, and here we're explicitly calling super, which is going to happen no matter what. All of that is implicit code that's going to happen whether you write it there or not. There's no reason to write this. It's going to happen automatically. All right, and then calling a overloaded constructor. So here we have a public class student. It has a name, and it has a default constructor and an overloaded constructor. The default constructor sets the name to unknown. The overloaded sets it to a new name. And then we have a KSU student, which extends student. And public KSU student, the constructor for it, calls super and passes it unknown KSU student. If it didn't put that in there, the students would all be called unknown. By putting this in here, I'm calling this constructor, which is setting their name to unknown KSU student, which is somehow better. Access modifiers. So now that we're done with that, we're going to talk about the 4 levels of access modifiers, which we've been using all this time in the class, and I've given you very sloppy definitions. I'm going to give you a more precise definition for each of them now. This is still a little sloppy, but we're getting closer. Public basically means it's visible everywhere. Everyone can see it. Any methods inside of the class you're defining can mess with it. Any methods in your children's class can mess with it. And even methods in adjacent classes that are able to instantiate you will be able to mess with it. So public means anyone can read it, anyone can change it. Generally not what you want for attributes. Generally what you do want for methods. Anyone can call them. Private particularly means that it is only visible within the class. Generally, the children cannot see it, no one else can see it. Okay, so protected is a middle ground between those. This definition is not entirely accurate, but it's pretty close. A protected attribute is visible to you and your children. It's a little bit more complex than that, but that's the general thought. It's you and your children and some of the people that are in your package, which I'll explain in a moment. And then default varies by language. Default is, if you don't put in the word public or private, what do you get? And I've been telling you that default mostly is public, but that's not actually 100% true. So here's a chart that explains all of this. So first off, we have within the same class. If an attribute is public, yes, you can modify it. If the attribute is protected, yes, you can modify it. If the attribute is default, yes, you can modify it. And if the attribute is private, yes, you can modify it. So within the same class, it doesn't matter what you do, you're able to see it. So if your mammal has an IQ, anywhere in mammal you can read IQ, you can change IQ in the mammal class. Subclasses in the same package, public yes, protected yes, default yes, private no. Okay, so that's kind of what I've been telling you, which is that the children are allowed to only see it if it is public or protected. Default, I said, was basically public, but you'll see that doesn't exactly line up all the time. It mostly lines up, but it's not exactly. Default is actually slightly different than protected or public. It's somewhere in the middle. Okay, so what is a package? Well, in Java, you can have a class, and then you can have a bunch of classes that you might want to bundle together. So let's take an example. If you're writing a video game, as I mentioned, you might have good guys and bad guys as characters. And so you'd have a separate class for each one of the good guys and a separate class for each one of the bad guys. but it might make sense to put those into a package called characters. And then likewise, you might have a package called environment, which deals with the sky and the grass and the buildings and all of the other stuff that's in the game. And all of those classes are packaged together in buildings or in environment. And then you might have another one for weather, and you might have another one for gravity. You might have all these other packages that combine to make the game. So think of packages as a way of grouping a bunch of stuff together. And you simply make a package by at the top of a class specifying which package it's in. So you have two levels of things being able to see each other. You have packages and you have classes. In general, public is available everywhere, which is what I had said. And private is only available within the class, which is also what I said. The ones which are a bit more messy are the protected and the default, which vary based upon whether or not you're within the same package, whether you're in a subclass or a child class of a class in the package, and so on and so forth. So for the most part, you're going to use public and private. Protected is occasionally useful when you want it to be available to children, but not necessarily to people outside of your class. All right. So as we said, most things are public by default in Java. This is desirable for methods, but undesirable for attributes. Private members are not inherited and are not directly accessible in child class methods or properties. So again, if a method is private, only the parent can call that method. The person who, not the parent, the class that you wrote it in is the only class where it can be called. All right, so let's take an example. We have private int body temperature. We have a getter for get temperature, which returns the body temperature, and we have a change temp, which is a setter, which takes in a new temperature and sets it. So that's all in mammal. So to be clear, the actual attribute is private, but we have a public get temp and we have a protected change temp. In the dog, which extends mammal, that's a child of mammal, we don't have access to body temp because it's private, but we do have the ability to call change temp, which is something we can have inside of a change temp override if we wanted to. So we have a public override here that's making it so the dog makes change temp public, but it's calling the protected version above, and that's all valid. All right, so declaring instance variables as private and using getters and setters is what you should always be doing. That is good enforcement of encapsulation. A change in a parent's class propagates down to the child class. What that means is everything that you wrote in the parent that is public or protected is inherited by the child, and any changes that it made from its parents are also inherited by the child. Constructors are not inherited, so you don't get the constructor from above. You have to write your own constructor in each class, and if you think about that for just a second, you'll realize it would make no sense if you were inheriting a constructor, because that's dealing with variables that are in the parent that you probably don't have access to. And a class's object's default constructor does nothing except set all the variables to their default value, and it is always called. Inheritance allows you to absorb from one parent to the child. It doesn't absorb constructors or private members. You can only inherit from one class. You can access parents' methods using the super if you need it, but really you can just call all of the parents' public methods. And access modifiers change what's inherited and what is visible. Okay, so that is our first lecture in Module 3. That is the topic of inheritance. It's very important that you understand this before you move on. So if this is not making sense, please go to tutoring and ask for some help about inheritance. Please come to my office hours or to your instructor's office hours. Please ask questions. It's very important that you understand this because all the remaining material in this module assumes that you understand inheritance. So go make some examples, practice with them, make sure you understand it, and I will see you guys in the next video.